Yes. So what we're doing today is we're going to go over the review sheet, and the test will be tomorrow. Now, are there any questions on problems 1 through 4? So corresponding angles are the ones that match up or in the same location. So for us here, for the one that we have, we would have angle 8 and angle 1, angle 7 and 2, angle 4 and 5, angle 3 and 6. As they correspond to each other, they're in a similar location comparatively to the two lines. The alternate exterior would be 8 and then 7 and 5, because they're outside the two lines and on opposite sides of the transversal. Alternate interior angles are going to be between the two lines and on opposite sides of the transversal, so we would have 4 and then we would have 3 and 1 or 1 and 3. As long as you put the two together and make sure it's obvious that these two are the ones together and connected. And since we are talking about angles, we will need the angle markers on these. Consecutive interior angles would be and then and that's all we need to list for these. Use the figure to classify the angles as either corresponding alternate interior, alternate exterior, or consecutive interior angles. Is there one of these, 5 through 10, that y'all want to look at specifically? Well, we can look at number 6, so 8 and 9. 8 and 9, even though, because we do have multiple sets of lines, we actually have 4, and each 2 that are going in a similar direction are being cut by a transversal. 8 and 9 are between two lines and on the same side of the transversal, the line cutting them. So exactly they would be consecutive interior angles, consecutive interior angles on the same side of the line in between consecutive interior. Number 8, 6 and 13. Exactly. Because 6 is down here, 13 is down here, so they're on opposite sides and outside. So alternate exterior angles. Alternate exterior angles. Any other one of these that y'all want to look at? Are we good with 5 through 10? Yes? No? Okay. Questions on 11 through 15? By the way, Briar, do you have questions on 1 through 10? Any one of those specifically? Okay, so we're looking at 11 through 15. So naming the lines parallel skew, or parallel planes or perpendicular planes. So we could say name a line parallel to AE. Well, AE is right here. Now there are multiple lines that are parallel to AE. AF would be one, CG, and DH. But which one do we have to use? DH. And why would we use DH? Because it has to contain point H. It has to contain point H. It says it right there in the description. Line skew to BC. So BC is right here. So HG would be 1. I'd say HD, because it's HD contained within the plane for BC or DC. Sorry. Nope, that wouldn't work. Because DC. So HG wouldn't work. HE would. HE is the only one that would work. Because I had BC. If it was BC, then HG would work. Does that make sense? And it'd be good if I actually put it on the right line. DH, HD, or DH wouldn't work because since the line itself is, oh, Lord. Okay, I confused myself. HG and HD would work. Sorry. HG and HD would work. I confused myself because I was looking there, not at the right spot. Because it did ask for BC. HG is not contained in the plane. HD is not contained in the plane. So those do work. For some reason, I looked back at it and saw HB or CD instead of BC, which we were actually using. I looked at the problem above it. Because I think I actually wrote the answer to the one above it, didn't I? Yeah, okay. That makes more sense now. Any other questions after that? The other one that we can look at is plane AEF. Well, AEF is the plane back here. So the one that would be parallel to it would be plane H G what? D. HGD or HGC, one of those. Because we're really just wanting to name this plane here. Would be the two that are parallel to it. Now, if you're naming a plane, we do need plane in front of it. I'm not going to really need to put that in front. Do not put a line above it. Because HGD with a line above it really is nothing. Because if we're naming a line, we need how many points? 2. Or if they have actually named the line itself with a little letter at the end, we can name it that way. We do not use 3 letters to name a line. So having a line above it actually doesn't tell us anything. We would use plane in front of it. Any other questions on 11 through 15? We can look at 16 or 17. So what would be a line perpendicular to AE? So problem number 16. EH. Because it is going to be the line that intersects it, and we are assuming and pretty much told that this is a cube, and by the definition or properties of a cube, they are all right angles. And it tells us that also. Any other questions on 11 through 18 with this diagram? 17, so FG would be HG, yes. good with this here. Questions on 19 through 24. One of those that y'all want to look at. 20. Name a pair of perpendicular lines. Perpendicular lines intersect at what? Right angles, yes? Is there a right angle in the diagram? Up here at the top, yes? So we can say what? Perpendicular to BZ. And I'm going to move that here. Now, there are other ways we could have named it, because AB, that line AB, we could have named it as line AC, BA, BC, CB, CA. Any one of those three, name that same line, any of those combinations. For the other one, we could have used BZ, BP, ZB, ZP, PZ, or PB. Any of those would name that same line. As long as we're naming those two lines, they are perpendicular. Any other questions on this here? Any questions on 19 for our parallel? Because how many sets of parallel lines do we have? 2, yes? Because I could have said LJ is parallel to HI, or any combinations of naming those two lines, or our other two lines, IJ and QK, because those two are parallel. And the reason we know that they're parallel is because of our parallel symbols, because the sets of arrows will show that they are parallel. We just need to make sure that when we're doing that we're matching up the same number. Because when one set appears, any other that has one set of arrows is going to be parallel. The other, since they have two, they're parallel to each other. J, Z, and KP, because they're still naming these two lines. As long as it's naming the same line, that works. And again, on these here, especially if there's more than one way to name the line, I'm going to be looking for every single one. I'm not just going to be looking for that one setup that I named, like on, I think, the answer key where I put one way to name it. I will look for any of them. More likely, I'll be checking the diagram with the answers for these here than a key, because I'll be seeing, does it actually match up? Any other questions on this here? (25 through 29). So we have two parallel lines cut by a transversal. So with these here, the angles are going to be one of two things. They're either going to be what? So if they are alternate interior, that means that they are. So they're either going to add to 180, or if they don't add to 180, they're the same. They're congruent, right? Because we have two lines cut by a transversal, the angles are either going to be congruent or supplementary, add to 180. They're either going to be the same or add to 180. And in any of these, how many different angles will we have? 2, right? Because there's only going to be one of two angles, measures that we can have. So is there one of these in particular that you want to look at? (27). Now, if we look at problem number 27, we're told that this one angle is 98 degrees, yes? What do we know about angle 1? It's not corresponding. It starts with a V. Vertical angles. And vertical angles are the same, they're congruent. So angle 1 is going to be 98 degrees. Well, as you're saying, corresponding, well, since 98 is above and to the left, on the other side above and to the left, this would be This one here would be, have we got all of the ones that are going to be the same as 98? Which means the other ones are going to add up to be 180. So to find angle 2, it's going to add together to be 180. So we can take 180 and subtract 98. If we do that, we would get, so the measure of angle 2 is 82 degrees. Now, even though these here only ask for 2 specific angles, if it helps you to go on and put all the ones that are congruent, so the corresponding, the alternate interior, the alternate exterior, fill those in and actually fill it in, write it in on the diagram, go for it and work them all out. But heck, when we worked them all out, did that make it a little bit easier? I mean, yeah. So do that, because heck, if that helps you get them all, get them all. You don't have to go for just the 2 angles that are asked for. Any other questions on these here? There's another one on 25 through 29 that y'all want to look at. We can look at 29. So, like I just said, let's go on and just do all the ones that are congruent for 73 degrees and see what they are. Well, the corresponding spot for 73, because it's to the right and above, on the other line to the right and above would be right here, yes? Alternate exteriors for 73, since it's above and to the right, would be below and to the, all the way on the other side. And then our vertical angle would be right here. Yes? Alternate exterior, alternate interior, corresponding. We have those all set up, yes? Now, it doesn't matter which one we find, because I could find this one right here, because 73, either one of those 73s, and that angle make a straight line, so they add together to be 180. So we can take 180 and subtract 73, which will be 107. Well, the vertical angle would be right there, yes? Well, that means these 2 angles down here, 107, 107. Okay, well, it asks for the measure of angle 1 and 2. Well, what is the measure of angle 1? And what's the measure of angle 2? And that's it. So just by using those corresponding alternate interior, alternate exterior, and well, vertical angles or linear pairs, or we can use consecutive interior angles, we're able to find all of them, and well, hey, these are the 2 at once. Did that take any real extra time than just trying to find the 2? No. So if this helps you find them, especially those 2, go on and find them all, because it's not really asking for anything more than that. Any other questions on this here? Questions on 30, 31, or 32? Okay. 32. Are the 2 angles that they gave us corresponding angles? No, because they're both outside the parallel lines, yes? So they're not corresponding. So that means they could be alternate exterior since they're outside. Are they alternate sides of the transversal? Well, no. So that means they also can't be alternate interior. And since they're outside, they can't be consecutive interior. So alternate exterior would be opposite sides of the transversal. Are they on opposite sides of it? Well, no, they're both below it, yes. So corresponding alternate interior, alternate exterior are our only ways really for them to be congruent. So if they're not congruent, they have to be what? Add up to be 180. They have to be supplementary. So 3x plus 20 plus x minus 60 is equal to 180. Because if they're not corresponding angles, alternate interior or alternate exterior, they have to add together to be 180. This would technically be consecutive exterior angles. Just consecutive interior on the same side of the line in between the two lines. Consecutive exterior, same side of the transversal, but both outside. Now the first thing we can do is combine our like terms. So we have 3x plus x is 4x. 3 plus 1 would be 4. 20 minus 60 is negative 40. Have we combined all of our like terms? Do we have all the variables on one side? I'd say yes, because where are all the x's located? On the right side. So let's get everything else away from it. The first thing I would really do is use addition or subtraction first. And we can add 40 to both sides. This negative 40 plus 40 is 0, leaving us with just 4x equals 220. Now we've gotten rid of, there's no more addition and subtraction we can use. We have to use division. We would divide both sides by 4, which will tell us x is equal to 'and if I remember correctly, it's just asking for the value of x. It does not want to know the angles. So that's all we need to find. It's just asking for the value of x, so we're done. If it asks for the angles, we could plug it back in. And would these be realistic angles? Well, no. Because here we have x minus 60, yes? What's x? Well, it can't be negative. And over here, 3 times 55 is going to be 165 plus 20 was 185. They're not realistic angles. If you're wondering about the bonus on the last chapter where it added that piece at the end, explain why these aren't real angles. A similar setup, it really, once we plugged it back in, they didn't work out for our vertical angles. Yes, because those would be consecutive interior angles. Consecutive interior angles do add up to be 180 also. Do we want to look at 31 or 30? 30. So looking at this one here, are these consecutive, or not consecutive, corresponding angles, alternate interior or alternate exterior angles? Alternate exterior, yes. Alternate exterior angles are outside, but they would be congruent since we do have 2 parallel lines. So they're going to be equal to each other. So we can say 6x minus 30 is equal to 2x plus 90. Well, we have 6x on one side and 2x on the other, yes? We need to get them to be on the same side. I would personally subtract 2x from both sides because I want to keep the variable positive, the number in front of it, because 6 minus 2 is 4. 2 minus 6 would be negative 4. It'll still give us the same answer, but I prefer keeping positive numbers if I can. And exactly, we would add 30. Since the 30 is negative, we would add it because negative 30 plus 30 is 0. So we're left with 4x is equal to, and then we would Divide both sides by 4. And that's it. Any other questions on these here? Questions on 33 through 35. 33. Find the value of x that will make A parallel to B. So the ones we just did, these are going to be the exact same, except we're trying to find it so that it makes it parallel. The ones we did before, we were trying to find the value of x given that the lines are parallel. It doesn't really change anything. Because here, if these two lines are parallel, well, 140 and 2x minus 10 would be corresponding angles. Well, they are. And for the lines to be parallel, corresponding angles have to be congruent. Congruent means the So even with this here, if they're not corresponding angles, alternate interior, alternate exterior angles, what they're given, it means that they're going to have to add together to be 180 for the two lines to be parallel. Well, we can add 10 to both sides, which will tell us that 2x is equal to 150. And lastly, we would divide by 2, which tells us x is equal to. So when x is 75, these two lines would be parallel. And that's it. So we're still using the same things that we did on the last set of 3 for these. It's just they've rephrased the question a little bit, but the process is still the same. Questions on these here? Questions on 34, 35? We good with these here? Yes. Okay. Questions on 36 through 39? 37. Are these two angles alternate interior, alternate exterior, or corresponding angles? They're none of those, right? Are they consecutive interior angles? No. They're not parallel. Is there enough information to prove that they're parallel? No. The only way we could really get anywhere is if we knew the actual measures of the angles. Because all this is telling us on 36 through 39, I believe, is that the angles are congruent. It's not telling me what the actual measures are. So unless they are alternate interior, alternate exterior, or corresponding, one of those 3, then we really can't say that they're parallel. Because even if it is consecutive interior angles, if they're both 90, well, yes, they would be parallel. But they could also both be 30. Well, that wouldn't work because they would still have to add together to be 180. So unless it's one of those 3 corresponding alternate interior or alternate exterior, we can't say the lines are parallel unless we know specifically what the measure is. Then we could go further from there. So any other questions on 36 through 39? 39. So these two angles that are given with our marks, are they alternate interior, alternate exterior, or corresponding? They're alternate interior. This would be, yes. And we could say alternate interior. Angles, because they're alternate interior angles. Because it's really, we could actually say by the alternate interior angles converse. Because if given two lines cut by a transversal and the alternate interior angles are congruent, then the two lines are parallel. Yeah. I might just take yes or no, but let's see where we're at. Okay, we're so good. Questions on 40, 41, or 42? So this is what we did do yesterday. If you don't have that equation written down somewhere, it might be helpful to have it down. Because again, we use this every single time, yes? Because once we found the slope, we plugged the slope and the point given into it and got y by itself. Let's look at this one here specifically. Because does this one give us the slope? Well, I mean, it does, but is this equation in the correct form? No, we need this to be in y equals. So to get it in the correct form, really, I can just subtract 7x from both sides, which will tell me y is equal to negative 7x plus 6. Because I need it in that form. I need to get y by itself. Now, is 7x and 6, are they like terms? Well, no, one of them has x, the other doesn't. So we can't just combine those. We just put it next to it. So that tells me the slope of the line is negative 7. Y minus y1 equals m times x minus x1. Y minus. Our point is always in the form of x comma y, so our y value is 6 equals negative 7 times x minus negative 1. Now, if you do get to this point here and feel uncomfortable or not sure about how you do this or if you're doing it right, at least write this down, okay? Because that tells me that you were able to get at least to the starting point of finding the line. There might have been some errors in the process, so writing it out is helpful. Even if you don't think you're doing it 100% right, I would still write out your work because I can grade it from there. If you leave it blank, you will lose all points every time. Because at this point here, you've gotten the points for doing it. You've gotten the point for the slope. Now there's only 1 or 2 points for the actual equation. You've gotten the majority of the points at this point. Does that make sense? So now all we need to do is actually get y by itself. A negative and a negative make a. Then we're going to multiply through by the negative 7. Negative 7 times x is negative 7x. Negative 7 times positive 1 is negative 7. Add 6 to both sides. And we get y is equal to negative 7x minus 1. And that's it. Any other questions on this here? (43) through 45, I think these are the last 3. Yes? Or there might be one more. Oh yeah, slope of a line. We'll definitely need to get the equation for it. Here, perpendicular. For the perpendicular slope, we do what? We change and flip. Change and flip. Okay. We can just do this one here. So since the slope of the original equation is negative 1/2, we change the sign. So if it was negative to begin with, it's now positive. And if I flip it from 1 over 2, it becomes 2 over, which is the same as 2, because we could have 2 over 1, but 2 divided by 1 is just 2. So if we have a fraction with 1 on top, we flip it and it's just the whole number. Now we use our point, which is x comma y. So our y value is 15 is equal to 2 times x minus 9. The next thing we do is distribute the 2. 2 times x is 2 times negative 9 is so y equals 2x minus 3. And that's it. Any other questions on these here? Okay. Let's look at 46, 47, and 48. Because I think hopefully these are the last 3. 49 and 50. Okay. Yep. Again, to find the slope, y2 minus y1 over. So for line 1, we just plug it into the formula. So here our y values are 5 and 1. It doesn't matter which ones we picked, I just picked the 2 y values and plugged them in. Now since I picked the 5 first, its x value has to go first, which would be 4 minus 2. 5 minus 1 is, 4 minus 2 is, 4 divided by 2 is 2. Line 2, slope. So we have 4, 9, 4, and 2, negative 10. So we can say negative 10 minus 4. And since I chose negative 10 first, we would have 2 minus 9. Well, negative 10 minus 4 is negative. 2 minus 9 is negative 7. Well, negative 14 divided by negative 7 is? So they're parallel. If they are opposite reciprocals, if the signs are opposite and they're the flip of each other, then they are perpendicular. Another way we can check it is if we multiply the 2 slopes together, what we get, and if the result is negative 1, then they are perpendicular also. 49. So this one here, 0, 4, we will work through it. We may or may not get finished in time before the bell, but this is going to be one of the bonus questions. What we need to do here is just find the slope of each and every single line, and then determine which ones are parallel and which ones are perpendicular. So for line A, using our slope formula, we have negative 6, 6, and 0, 4. So I can say 6 minus 4 over negative 6 minus 0. Now at this point here, we could plug it into the calculator like with the last ones. We could have just plugged those into the calculator once we got it set up. But 6 minus 4 is, negative 6 minus 0 is, so this is negative 1/3 because 2 is smaller than the denominator. So it would simplify to 1/3. B. Line B will do the same thing. So we do have multiple points along this line. We have 0, 4, negative 2, 2, and negative 3, negative 5. We could use any of them. So I could say 4, 0, so 4 and 0, and then negative 2, negative 2. Well, on top, the negative and negative make a positive. So 4 plus 2 is 6. On bottom, the negative and negative make a positive. So 2, and 6 divided by 2 is 3. I just picked the point 0, 4 here, and this point negative 2, 2. I just picked those two on the line. C, slope. Well, we have this point over here, which is 6, 2. It just wasn't written in. We'd had to look at the graph itself. And then we have negative 4, 4. So we can say 2 minus negative 4 over 6 minus 4. Well, 2 minus negative 4 is the same as 2 plus 4, which is 6. 6 minus 4 is, which gives us 3. And last but not least, let's go on and find slope D before we, the slope of line D before we parallel and perpendicular. So line D is this one here. So we can say negative 4 minus negative 5, because those are the two y values of the points on that line. And then we have 4 and negative 5. Well, since we use negative 4 first, we have to use positive 4, because it's x value first, minus negative 3. 1, 4, and 3 is, so it's 1/7. Now, D is parallel to C. Now, the opposite reciprocal of 3, opposite would make it negative, and 3 would become 1/3. So B is perpendicular to A. Well, C would also be perpendicular to A by the same reasoning. But really, if a line is perpendicular to a line that's parallel, or perpendicular to one, and that line's parallel to another, most likely they're also going to be perpendicular. And that is it. So guys, your test is tomorrow, and all of the homework is due at the end of the day tomorrow.